In this problem, we are given the following circuit diagram. We need to use the node voltage method to find the following phasor values as well. We have our V0 and our I0. Now for this, we're going to take two nodes. We're going to use this node and this node here and start this problem off with a node voltage analysis. It even tells us to do it right here. We're going to call the voltage across our 20 ohm resistor V1, and then we're going to call the voltage across our 25 ohm resistor V0. Since it's in parallel with our V0, it's going to be the same thing, since we know that voltages in parallel are the same. Starting off with the left side, we see that we have some current going into our node. That means we are going to have a negative 17 with our 0 degrees here. Now we have our V1, it's going out of our node, so we will have a plus V1, and this is happening over the 20 ohm resistor. Now we have voltage going across this inductor. So we will have a plus V1 minus our V0 over 4, and this is happening over our J40 because it's happening over the inductor. And this is all set equal to 0. Now we are going to simplify this. After a little bit of simplification, this is what we get. Now we are going to go inside of our V1, and we're going to say that our V1, and then in parentheses 0.05, and then when we look at this, we are having a 1 divided by our 40, which gives us 0.025. However, we have a j here, and if we flip this j around, we are going to have a negative. So this will be a negative j times 0.025. And that's how we can get the j to the numerator from the denominator. We're going to do the same thing with our V0. We will have a plus, because if we flip the j, we'll have a negative j, and a negative times a negative is a positive. That's why we have a positive here. And then we're just going to have our j times the V0 times 1 divided by 160, which is 0.00625. And this is the equation for the first part. Now we need to go about finding our V0. For the second equation, we can see that we have some current going out of our node, so we are going to have a positive 32 I0. We can see that our voltage is also going out of our node, so we're going to have a plus V0 over our 25 ohm resistor. We also have voltage going out of the node this way, so we are going to have a plus V0, and this is over the negative J50, set equal to 0. We have another unknown, which is this I0 right here. We can find this by setting I0 equal to, and then we're looking at this part, by the way. We're looking at over here to solve for this. And it's equal to the V1 minus the V0 over 4, because this is the current going through it, if we divide it by the impedance. And the impedance is J40. This is going to be our I0. Before we plug it in, we can simplify it a little bit. We're going to write this as our I0 is equal to 4 V1 minus V0 over J160. And basically what we did was just multiply everything by 4. From here, we're plugging this back into our equation. After we do that, we are going to get this equation. I also simplified our V0 right here a little bit. And then we can simplify this further by factoring this into here. Also, make sure when we do this, we flip the j on top. So we're going to get a negative j, and this is being multiplied by our 0.8. if we factor this in for our V1. So we're also going to have a V1 here. Now we're going to have a plus, again, because if we flip the j up, it's going to be a negative, and a negative times a negative is a positive. And then we just have 32 divided by 160, which we know to be 0.2. So we're going to have a plus 0.2 times our V0. And then we have our V0 here that we can just copy in. After this, we are going to simplify a little bit further and add the V0s together. And we're also going to move it to the right side. Quick side note, I forgot that there should be a j in here. Remember that there is a j because of this j goes in here. Forgot to factor that in when I was doing that. So that's super important to remember. This is a pretty long problem, so if you mess up early, it's going to mess the entire thing up. But anyways, we're on the right track so far, so we can add our 0.2j to our 0.02j. And if we do this, we're going to get 0.22. Now we're going to move this to the right side. So we're going to have a negative V0, and then in here we have the constant 0.04 plus our j times 0.22. Now we have our V1 here, and if we get our V1 alone, we can plug it into our first equation here to solve for our V0. So to do this, what I'm going to do is divide both sides by a negative 1. That'll get rid of this negative. And then I'm going to also divide both sides by a j 0.8. And what that'll do is cancel out the 0.8 and j on this side, leaving us with just a v1 over here. We can simplify this even a little bit further. We'll say that our v1 is equal to our v0, and then inside of here, we're going to have our 0.04 divided by 0.8. And this is going to give us the value of 0.05. We have a j in here, so if we flip that up, it's going to be a negative. We'll have a negative j times 0.05. And now we need to do it for the next one. We have a j 0.22 and a j 0.8. So what we're going to do is cancel out the j's and just divide 0.22 by 0.8. And this is going to give us 0.275. It's important you keep all of these numbers. Don't round anything because this problem is pretty precise. And this is going to be the equation for our v of 1. Now, since we've solved that, we're going to plug it into this equation right here. Now this is going to be the entire equation that we end up working with. From here, we are going to just multiply these. So we're going to multiply this by this, and then this by this, and then this part by this part, and this part by this part, and then add them all together. From this, we are going to get a 0.0125 minus j times 0.009375. And then to this, we are going to add the rest of our problem right here. We know that we can add this j to this j, and this is going to give us approximately negative 0.003125j. Now we want our v0 by itself, so we're going to set our v0 equal to our 17 with our angle 0, and then underneath it, we are going to move this part over. We're going to divide both sides by it. So for here, we're going to have 0.0125, and remember we added the parts underlined in green, and this will give us a negative j 0.003125. Now we have to convert these into like terms because currently it's in polar and a rectangular form, and we can't stand for that. So we're going to have to convert this to polar. We're going to convert the bottom part. To do this, we are going to set our Vm equal to the square root of our real number, I'll just call this r, and we're going to square it, plus the imaginary number squared. And then we're going to set this theta equal to tangent of -1 with our imaginary number on top divided by our real number. So if we plug this into a calculator, we're going to have the square root of 0.0125 squared plus negative 0.003125 squared. Make sure that negative's in parentheses so you don't accidentally subtract them. And I'll write this back into our formula. We're going to have our v0 is equal to 17 with our 0, and this is over, currently if we did our Vm, going to give us 0.012885. Remember, these numbers are super important. Don't just round them here because we still have a lot left to go. And now we're finding our angle. This is going to be the tangent of -1, and then we are going to have the negative 0.003125 divided by our 0.0125. And this gives us the value of negative 14.036. Now we are going to take the first part, the numbers, and divide them, and take this next part and subtract them. We're subtracting the bottom from our top. If we do this, we are going to get that our v0 is equal to 1319.3938. And then we're going to have the angle of 14.036. Now, this is almost our v0. We need to convert it back to the rectangular form. And to do this, we are going to set our number on the outside, which is 1319.3938. And then on the inside, we are going to have a cosine of our angle plus j times the sine of our angle. Remember, our angle is 14.036. And if we do this, we are going to get that our v0 is equivalent to 1280 plus j times 320. That is going to be the rectangular form. Remember, this is our polar form. It'll come in useful in a second. But when we write this as our answer, we are going to, in our question, write 1280 and 320 here. Now we need to find our I0. Well, conveniently, we wrote a formula right here for it. So we can use this formula to find our I0. Before we start solving this, we know that we have a V1 here. However, we don't know our V1. We only have an equation for it. But we do know our V0. So we can plug this V0 in here and find our V1. We're going to say that our V1 is equal to our V0, which we know to be this value here. So we're just going to multiply it by this value. We'll multiply these two together. We'll multiply these two together, these two, and then these as well. And this is going to give us a 368 plus j times 24. And this is going to be our V1 values. And now we can just plug it back into our I0. We have this here. We know it's going to be over our J160. And then we can plug in our V0 for the V0 portion. Remember, there's a minus sign out front, so we're going to have a negative 1280 or a minus 1280 minus J320 as well. Now we can add all these together. And from this, we are going to get 192 minus J of 224. And this is all over our J of 160. If we divide these out, we are going to get that our I0 is equal to negative J 1.2. So we're going to put this over here. And then remember, our J's are going to cancel out, so we're just going to have a negative 1.4. And this is going to be the answer for this part. Plugging this back into our equation, we're going to write a negative 1.4 for this part, and then the negative 1.2 for this part. And that is how you would go about solving this problem. If you have any questions about this problem or the material that we covered here, you can leave them in the comments below. If you want more introduction to circuit analysis or notes covering the entire coursework, there are links to a playlist and notes below the like button in the description.